Welcome to a new lesson. In this lesson, we are going to look at RIP version 2. To configure RIP version 2, or RIP basically, you have to go into the configuration terminal here and then type router RIP. Now, this is us telling the router that we are now going to use RIP routing protocol, and then we are going to configure the needs of that RIP routing protocol. Notice that once we finish router RIP here, the prompt changes to config router. So we are now going to configure the routing protocol. If you see here and you put the question mark, you would see what else can you do within that prompt. And the commands in the orange color are the ones we will be using in this lesson. If you make a mistake, oh, I spelled it wrongly, or I put up a wrong network address, doesn't matter, just say no router RIP. No router RIP will disable RIP, and then it will not be in your running config anymore. Now, because this is a dynamic route, and in dynamic routes, you want to tell your neighbors, advertise to your neighbors, the knowledge that you have, the routes that you know, the networks that you know. So, in this particular example, this is router 1. Router 1 is going to be configured with RIP. And what are the networks that router 1 knows? He knows this network, which is 192.168.1.0, and he knows this network, which is 192.168.2.0. Those are two things that he knows. So those are the two things that is put within here. Network 192.168.1.0, network 192.168.2.0. Notice this is the network address, not the IP address. So this is the thing, or this is the information that will be advertised to his neighboring router every 30 seconds. So this is the basic of RIP version 1, and RIP version 1 is class 4. If you remember when we talked about class 4 is very early on in the networks, in history. In fact, we don't use it anymore. And it has very specific boundaries of class A, class B, class C, and they don't mix. Later the VLSM, CIDR came about. So right now we're going to focus on just RIP version 1 first. Now that we have done our configuration, we can actually verify that we are actually running RIP. So how do we verify it? We use show IP protocols. So if you type this is the basic thing you will get from that. It will tell you that the routing protocol is RIP. It will send updates every 30 seconds, and the next update is due in 16 seconds. It is invalid after 180 seconds, meaning that if everything is quiet for 180 seconds, that means no new update, that route is dead. Okay? Hold down and flush timers are used. Flush is to flush it out of your routing table. Hold down is how long you hold before you flush it out. Default version, you're sending in version 1, you're receiving in any version. Okay, and these are the two interfaces that is connected to those two network addresses that we configured before. So, automatic network summarization is in effect. Okay, routing for networks, these are the ones that we configured. And then routing information sources, like these are the gateway for the router. So distance here, the default is 120 because it's RIP. Another way to verify RIP routing is, of course, through the routing table. Now, once you configure routes on all the routers on your network. Then they will start to exchange advertisement, and you want to see whether or not it is right. You will look at the routing table. So here you will see that router 1 has learned 3 new routes: 192.168.3.0, 4.0, and 5.0. And these are routes he learned via RIP, meaning these are remote routes that it is learned via RIP from the advertisement given by his neighbor. And this is the exit interface for which it has to go out. Okay, looking at this, you would see you have to go through this interface, this IP address, which is on this interface. So let's do a task. I've given you a packet tracer file. Please open that, pause this video, do the task, and then come back. Okay, so in the task, I gave you a packet tracer. It kind of looks like this. All the network information has been configured. These are the network address for this network, and then this is the network address for this network, and so on. All the IP addresses are also configured. What is not configured is the routing protocol. So please do that. In the packet tracer video, you would have something like this. And you have to configure this router and this router. And then you have to answer a few questions. Please do that before going on to the next slide. I believe that you have done task 1. You have configured RTA and RTB. You have pinged PCA and PCB. Okay, and then you have looked at the routing table of both, and it was okay. When you configured this one, then you have a problem. So what is the problem? Notice that when you try to ping between PCA and PCB, when you try to ping this, it came out like this. Originally, it was all okay, it wasn't a problem. But after you configured RTC, then you have this, timed out, and then destination unreachable, and then it was okay, and then destination unreachable. Now, the problem is, once you have configured RTC, the router in RTB would have 2 routes to the same network, and it has a eco route, eco cost route, and now it has to do balancing, load balancing. So if you see here, this one, it was sending it in the other way, this one on the right way, this one on the other way. So load balancing here happens. You see that? Load balancing happens. So in router B, you would see that this particular route, there are 2 of that because they are equal cost, and they will be load balancing. Now, they are not the same route. Why does it report it as the same? It's going to 2 different places. It is because RIP version 1 is class 4. Auto-summarize the networks that you put in according to class. Now, 172, if you remember, is class B. In class B, the subnet mask is /16. That means it will take this one and this one. So 8 and 8 will give you 16 bits. So it will look at the 16 bits. That is why, even though these 2 are different networks, it will auto-summarize it, and then you will get it to be the same. Hence, the problem we have here. So how do we not do this? How do we overcome this problem? That's where RIP version 2 comes in. Now, RIP version 2 has moved beyond class 4 and can handle classless. But you have to tell the router that you are using version 2. That is why under the router RIP, you have to type version 2. You are now telling the router, yes, I am using RIP, but I am using RIP version 2. And you would see in show IP protocols how it has changed. It is now send version 2, receive version 2. Now version 2 cannot receive version 1. Only receive version 2. So be sure to that. Make sure that All the routers here uses version 2 as well. And go through the same thing, show IP protocol, show IP route, to check how things are different. Another thing within version 2 that it gives you is the command no auto summary. It doesn't work if it's version 1. It only works in version 2. So you can type no auto summary, telling the router don't auto summarize. Whatever I write, that is it, use it, and it will not auto summarize. If you want to see whether or not you did this command, you can check under show IP protocols, and then it will show you automatic network summarization is not in effect. Okay. Another thing in version 2 here is the passive interface. Now remember, a router will send advertisement out of all its interfaces every 30 seconds. So this is a switch. He doesn't need to know about routing. Why does this switch need advertisement? That is a waste of bandwidth. Okay, that is a waste of bandwidth. So what we can do is we can make this particular route a passive interface. Okay, this particular interface here, a passive interface. So that means when router 1 is sending advertisement, it only sends out this interface and not to this interface. Okay, so how do we do that? Very simple. Under router RIP, type passive interface, which is the passive interface, you write down the interface name. So this is G0/0. Then you go back, and if you want to verify what you have done, you type show IP protocols, and then you would see here that you would have a passive interface, that is gigabit 0/0. Okay, right. Let's move on to task 2. Task 2 would require you to use version 2 on the routers that you have already configured in task 1. Pause this video, start task 2. Once you've done task 2, we are now going to learn about default route. Okay? Now, default route, if you remember static route is not advertised. That's why it was secure. It was not advertised. So how do you tell your neighbor that you have a route to somewhere? For example, here, router 1 has a route to the internet. And this route is a default route. Okay? IP route 000, 000. Remember, this means any network, any subnet will be going out of serial 001 here, and then to the IP address of, or the next hop IP 209.165.200.226. This is configured. All right. And then under router RIP, if you want to tell your neighbor about this route that you have, you type default information originate. Okay. Now this command will tell the router to make a place in the advertisement for this default route. Default route only. Okay, not static route, but default route. So in the routing table of R1, you will see here, this is the default route. Okay, this is star, so it's the default route here. And then in the next advertisement that R1 sends to its neighbor R2, that route will be put in there. Try that one for now. Pause this video and try that task 3. Once you have done that, you would see that in RTA, in RTB, in RTA where you put this default route, it is there. And then in RTB, the default route is there, but it is learned via RIP. Meaning that that static route or that default route has hitched a ride on the advertisement from RTA to RTB, and it is now there. So because it hitched on the RIP advertisement, That's why you would have R and star here. Cool, huh? So we are done with rib. Easy peasy, lemon squeezy. Practice makes perfect. I'll give you some labs, review that, and then revisit the task so that you can have a better grasp. Until next time, see you.